Thank you for the opportunity. So this is just a beginner course on Mathematica. It's not for professionals. So for those who have some knowledge of Mathematica already. So the aim is just to make our students to appreciate what we have taught them, how to use Mathematica to solve some of the mathematical problems that they have learned over the years in maybe from 101, 102, and 202, and what some of them are doing at the moment, which is 301. So we want them to appreciate how it's used to solve some problems. So it's basically the beginners. So I'm expecting the students to join, so though many of them have not joined yet. So we'll go through some of the commands because it's when you have the experience or you have a little knowledge, you can develop, you can build on them. Okay, so we know that Mathematica is a tool that can be used to solve very complex and both simple mathematical problems. So it does the work of a calculator too. So Mathematica is a yes, many students are yet to join. So they're yet to join. So we believe they will join us very soon because they're all away. Okay. So it does the work of a calculator. Great. So unfortunately here, Mathematica does not tell us the full steps, step by steps of how to solve mathematical problems. What it does is it will give us a quick answer. Sometimes all of these mathematics, maybe you don't want to, it doesn't stop you from knowing the steps. It doesn't prevent you from knowing the details. But what it does is that it gives you a quick answer. I mean, from the basic, because there are other levels of Mathematica that you need to write programs, you need to write sequences. It does a lot of things. So a lot of things you can use Mathematica to do, but it depends on your area and what you want to use it for. So there's a lot one can use. Even engineers, they use it. A lot of algorithm can be used, can be formed in a Mathematica. So we just do the basic so that our students and some of us lecturers that don't have the knowledge before can appreciate. So we just introduce a little. We'll be doing step. I'll be showing. I will tell us some of the commands, and then we'll practice it also. I earlier sent a free version to some students, so I expect them to download them. I expect them to log in, register, so that you can, even from home, you can use your laptop to practice. So let's see what we have. Now, for you to press anything on the Mathematica, for you to do any command to give you an answer, to give you a result, the two keys that are very important is the shift key and the enter key. So you have to hold the shift key and then you press the enter key. All right, so so that's what we have to do. Now let's begin. It does basic mathematics operations. The basic mathematics operations of addition, the subtraction, the multiplication, the division. It does all of this. Very easy. These ones are not hard to do. These ones, nothing. Just the way we write mathematics or addition or subtraction or multiplication. You can do it inside the note of the Mathematica, and then you hold your shift key and press enter, and it does the work for you. For example, if you want to do an addition or multiplication, so you just quickly add these two numbers. Just type A plus B. You hold your enter key, shift key, and enter, and press enter, and gives you the answer. So same as subtraction. Then for multiplication, you have to use this star. Use this to multiply. Then for division, if you just want to simplify, you want to divide two numbers, you can use this, just the slash sign, and it gives you the number. It may give you in fraction. But if you want numerical value for your fractions, what you do is you have to attach n at the end. So you just write n, and then you write your division or your fractions, and it will do the work. So these are the basic arithmetic operations that it can do. So we can look at how we can do this one. All right, so let's see how we can use it. Let's see how we can use it. So let me go to our to Mathematica and do some of these examples. So let me add. Okay, 1 minute. So let me share. Okay, so this is the mathematical note. This is the mathematical note. So many things here. Like I said, when you've known the basic, you can use the help to search for anything that you want to have more knowledge. So you see, if you open, there are a lot of information, there are a lot of different things depending on what you want to do. Then you can click and it gives you hints on how to solve them. So like data multiplication, those in data analysis, there's so many things, machine learning. So there are so many things that we can use. Us, we just want to appreciate what we have learned in mathematics and how this can solve. So let's try. For example, if we want to do any addition, I type two numbers, 3 plus 7, for example. You just hold the shift key and press enter. Nothing more, it gives you the answer. It does the work of calculator. So you see, it's like a calculator. Then 12 minus 5, you hold your shift key, you press enter. So if you have installed Mathematica, you can be practicing along. So that's how we do this. So you see, it's easy. So, but if you want to multiply, so write your numbers, and then use this star, and then say multiply by 8. Hold your shift and press enter, and it gives you what you want. Okay. So that is for some of this arithmetic. Now, if you want to divide, for example, I have 6 divided by 3. So this can simplify. But if it is something that you cannot simplify, let me say 9 divided by 4. To give us the same. But now, if I want the numerical value of this, I will put n, and then put the number, say 9 divided by 4, hold your shift key and press enter. It will give you the numerical value. So that's how we use this one. Good. So that's the first thing we need. So the simple arithmetic can be done. Okay, so let's go back. So we'll go back to our notes, to slide. All right, so next, what if we want to differentiate? So if you want to differentiate functions, the command is the following. So you write D. D stands for derivative. So you write the function you want to differentiate, and then the variable that you are differentiating with respect to, just the same way we write the f dx or the y dx. So f is the function you are differentiating, and then x is the variable. Then that's the command we use for derivative. Next is if we want to differentiate many times. Suppose you have a function, you want to differentiate it several times. So what you do, use the command is the same D because it's derivative. Then you write your function. X is the variable. N is the number of times you want to differentiate. N is the number of times you want to differentiate. So that's the command we use. Good. So that's for derivative. And we can see some of the functions. So if you have your own, now we can practice. So check, write derivative, put a function that you know, and then write x and see what you will give. And also if you want to differentiate many times, so you know we have first derivative, second derivative, third derivative. So that's how we do this. Okay. So let me just show you a little example. So everything, just write the function. I was able to put these ones together. So these are some functions we know the derivative. These are functions we know how to differentiate. So I will just write one or two, and then we'll continue. We'll write one or two on how to apply this. Okay, so 1 minute will be changing from here to the Mathematica. Yes? Somebody is raising hand. Okay, so let's move on. Yes, doctor, you're raising hand. You're doing. Dr. Edwin, you have questions?
I think we can postpone the questions to the end of the session.
Okay.
Okay, doctor, I wanted to ask if we can put a function of more than one variable or an implicit function.
Yes, you can put partial derivative. You understand?
Okay.
You can put partial derivative. The same, but now you have to, for example, okay, let's do that together. So it's the same command. For example, let's do that. Let's practice that. Okay, so if we have more than is the derivative, so we want to find, for example, this is x squared y. So this is a function of two variables. So the question is, which one do we want to differentiate with respect to? Do you want to differentiate with respect to x? You see that? Now, if you want to differentiate with respect to y, you just specify, this is a partial derivative. So you specify the variable you want it to. You see, with respect to y, it gives you. So you can do all, you can do it for sure. So, all right. And then let me see when you want to differentiate several variables. I mean, a number of times. So we have x, let's say exponential, for example. If I say exponential function, exponential function 2 times x, for example, and then remember, if you want to differentiate several times, you have to use braces, and then you write your variable, and then you write how many times you want to differentiate it. Suppose you want to differentiate it 2 times, then this is the answer. This is the second derivative of this function. If you want more, you now put the number here, tells us how many times we want to differentiate the function. How many times we want to differentiate the function. Oh, good. So let's continue. I don't know why many of our students are not here yet. Okay, so let's go back. So now let's look at integral. Good. So anybody can, since we're recording, can pick this. What you have to do is just, if you know the command, you cannot always get it done. So if you want to integrate, so if it is indefinite integral, just this one, you have to write the word integrate. That is the command, integrate. Then you write the function you want to integrate, and then the variable you want to integrate with. Just the same way we did in a derivative. But when we are dealing with definite integral, then you write integrate, you write your f, and then you specify the limits. So you have your x minimum and the x maximum, the lower limit and the upper limit. So that's how to use integration. So these are the popular ones we know. So we'll now practice few of them and then we'll move on. Okay, so let's see one or two.
Excuse me, I noticed that you always write the function with a capital letter, capital C
Yes.
for cosine, capital S for sine. This should be in Mathematica done in this way, or else it would not understand the function. Yeah.
Yeah, it will not. Let's try one. Let's see. Suppose we want to, let's even say let's use derivative, for example. We want to differentiate sine. Let's say sine. You will not see it. Sine x. And you see, this, when you write function, you use this bracket, not open bracket, it's a closed bracket. So x. Oh, you don't see it. Does he see it? No. Do you see? It doesn't understand.
Yeah.
So
Doesn't
it must
recognize
be a
it,
capital.
function.
It doesn't recognize this. So if immediately you put a capital, then it does. All right. So let's use integral. Integrate. For example, we want to integrate. Let's say, okay, let's see the basic that everybody knows about. Okay. So it gives us the function. So this is, but in this case, it doesn't give us the what do you call it, the constant of integration. It doesn't give us. But the only difference is that it is a function. But if we integrate with a limit, it gives us a number. For example, if I say, let's integrate cosine x Now we want to specify the limit. You put x, which is a variable, and then say we want to integrate from 0 to pi upon 2. Now see pi here, and I use capital Pi. So if we integrate this, what will it give us? It gives us 1. Okay. So both complex integrals, you put it here, it will give you. So that is that. So let me put, still the same. I think it's okay. So for example, if I say integrate, say logarithm.
So even an integral that is not convergent, is it possible it would give the answer that is not convergent?
No, if it's not convergent, it will tell you that it doesn't exist. You understand? Immediately tell you.
Okay.
So let's see one. For example, this is log. Okay, log x. So suppose we integrate from x from 0 to 1. What's integral of log?
Please, doctor, maybe can you test the one that is not convergent? So let's see what it would give.
Yes, let's check integral that does not converge. Which one? For example, if I say integrate,
You can take 1 over x from 0 to
yes,
1.
1 over x. So I want to the x from 0 to 1, for example. So you see, this integral does not converge. So it will tell you.
Okay.
Yes, it tell you that it does not work. Okay, so let's move on. Our students, I hope you are here. So that we know that some of you are here. So that
I'm not seeing any student, doctor. It's only also.
There's some students are here, where there are few. Yes. Okay. So let's look at some special. Yeah. Some students are here. No. Faris is here. Okay. So if you're a student, you indicate so that we know. Abazi is here. Hassan is here. So there are a few students. Good. Okay. Any of you, were you able to download? Were you able to log in? The link I sent to you? Because it's good that you're practicing, you're following us as we're doing at the same time. So this one is not like a lecture. This is more of practice. Okay, so let's move on. So let's see some special integrals. Of course, in 301 that we're teaching them, we know how long it took us to prove that gamma function of half is equal to root pi. So what this does sometimes, just to give us a quick answer, then you continue what you are doing, or you are solving. It will give you a hint that this is the answer. Then you work towards getting your answer. So that's some of the things Mathematica helps us to do. So we've learned in our modules, this is one of the special functions, one of the improper integral, a gamma function. So here you write it as the function gamma of the number you want to evaluate. Gamma of minus. So this one, I think these are examples, even the course we are doing now. So this we just give us what we know. We don't have to start solving, which takes at least 10 to 15 minutes to do. We also learned the Laplace transform. So for us to use Laplace transform to evaluate Laplace transform, it's just the same way. You write it in full, Laplace transform. You write the function. Remember, it's a function of t, but the Laplace transform, it will be a function of s. So you just put the two variables here. F of t, then you write t, and then you write s. So that's how to perform those ones. Okay, so these are some of the examples. This we know in class how to find. We're already giving our students this formula. I mean, how to find that the Laplace transform exponential at is 1 over s minus a, where a is a real number. So this is what we know. And more importantly is, I'm not sure, this one is not even a module. If you want to find a Laplace transform of functions or two variables, so this one is, it will take time even to compute with hand. So if you have a function of two variables, so how do you find the Laplace transform? So you just write, in this case now, because there are two variables, you write the variables, and then you write what the, also as the two variables also, because the Laplace transform, just as we have Laplace transform of a function of t, which will be a function of s. So this one, it depends on what we call it. You can use a or b, or can use m and n. So it will just give us the Laplace transform of it. Okay, so let's put this one. Let's do this one. So do a few of them. Okay, so let's see Laplace transform. Okay, or even gamma, for example, gamma of half, simply root pi, gamma of minus 3 upon 2, for example, 4 over 3 root pi. Now, if we want to find the Laplace transform, so this is Laplace, this is already here, Laplace transform. So let's do for two variables. For example, I have x cubed times y squared plus x y. I want to find the Laplace transform of this function. So write the function, the variables are x comma y. Okay. And then the Laplace transform variable. So if we're saying m and n, you press. So which this, I'm sure we didn't even teach our students this one, because this one is going to be long, even to evaluate this Laplace transform of two variables. But for one variable, they all should know. This one we taught in class, so you can just quickly confirm what you know before. For example, if we have Laplace transform of t cube, for example, what this will give us, just write your t and then write, for example, s to give us what we know. So pretty easy to use. Pretty simple. So next we look at is how we can use this to plot graphs. How to use it and plot some simple graph. Of course, there are so many complicated graphs we can use it to do. Yes, doctor?
Yeah, I was saying, I don't know, because when you enter these functions, you just press
Yes.
something and then we see the the answer.
Yes.
So I hope the students know what to press in terms of, and for instance, like let's say you want to enter special variable like alpha, beta, theta, things like that, how to
Yes.
enter this type
This
first.
Yeah, to press from the beginning. I said before you run any, you have to hold your shift key and press enter. And
Okay,
press
good.
enter. So I've said it from the beginning.
Okay.
Also, to use special character is here. Like I said also from the beginning, there are a lot of things one can learn here. Just for you to have, just what we are teaching, what we want to do is to have a basic knowledge of it. Then you can now come here, and then there are a lot of things here that one can search. So like if you want to put special characters, here you see palette, you can see basic math assist, you can see special character, for example. See here, you can see alpha, beta, and all of that. So, okay, thank you. So let's move on and plot, show you the command for plot. Okay, let's do that. Let's look at the plots. Good. If you want to plot, if you have for a single plot, so write the function and write the interval that we want to plot, the interval of x. Write the function, write plot, write the function, and then the interval or the range of values of x. And also for if you want to plot several variables, so here you have to write the variables that you have, and then the functions, several functions that you have, and then also specify. Okay. Same way you can also solve several variables. Just the same way you specified x, also you have to use the same comma and specify y. Suppose you have each one is a function of x and y, for example. Okay, so these are for single plus or several plus. Now for two-dimensional functions, so we use 3D. So in this case, you say plot 3D. You write the function, then you write the variable. Okay. So here, F1, F2, if they are, so this one a function of two variables, and this one now function of two variables, but there are several of them. So we use all of this. So let's look at a few examples. I don't know. I want to hear feedback from students if anyone downloaded or anyone is practicing at all. Yes, any of the students who is following us, who is practicing at all? Anyone at all?
I think
Okay,
we
so
can practice it later on in a laboratory face to face. So today we will just
oh,
learn how to do that theoretically.
oh,
Yeah.
Okay, okay. It's good, Elaine. Okay, that's fine. So let's continue. So I have a plot. All right, that's good, Faris. So if we want to plot for a single function, for example, I have x cubed plus 2x minus 1. So this is the function I want to plot, and then we specify the range. Suppose we say from -3 to 5, for example, and then let's see how it works. So this is the graph of the function. Okay, but if we have several, let's see, several functions, but they are single functions of one variable only, but several of them. For example, we have sine x, and then cosine 2x, for example. And now we specify our values of x. For example, if you say from minus 2 pi to 2 pi, for example. Let me see if this will run like this. If I don't multiply. Okay, yes, you cannot. By 2 pi, exit. Okay, so let me write cos x only. All right, let me see 3 pi to 3 pi. Most times, yes, I think so. Yes. So what's happening? Okay, these are two variables, so I have to put this command. Very good. Very good. So these small things to not work. Okay, so we have to put this bracket sign because now it is more than one variable, so you can see all of them as one. Very good. So that is it. And if we have several of them, for example, let me put more and see how it will be. If I say sine x, sine 2x, sine 3x. So you see several of them. Okay, so let's quickly go through the remaining. Okay, let's quickly go through the rest of them. So anybody that knows has this can quickly, comfortably put the command. So let's just run through the commands and then we'll end because time is very much gone. So that's how to plot. Like I said, you have several variables. So even good that we try this 3D. Please, 1 minute, okay? Let's try this 3D and see how it looks. This 3D is very good, very important. Then we'll now finish up. So let's do this 3D. Okay, So let's do 3D plot. Plots 3D. Then we have suppose we have x. Let's see, x squared plus y squared, for example. And then we have two variables now. Suppose we have x is between -1 to 2 and y is between -2 and 2. So this is a 3D. This is what it will show us. But if we have more than one variable, so if I have two functions, for example, if I put here braces, and I want to write, so let's see, x squared multiplied by times sine y, then comma, and then I have x plus. So a lot we can do with this. So this is a 3D. Okay, so let's just quickly round up. So those that are interested, when we're making plans to use the laboratory, so we'll install some of this software, install the software, then we can practice together. So this is how to use the plots. And also we can solve differential equation also here. To solve differential equation, use dsolve. Dsolve, you write the equation you want to solve, then you write the function, this is the function, and then you write the variable. So these are the three things we need to solve the differential equation. And very importantly is that you must put double equality. So you write y prime, then, and in this case, you don't write only y prime. You must put the variable you want, you're using the variable here. So you see y prime of x minus the minus na multiplied by y. Then this should be equal, double equality before it can solve. If you put this command, it will solve this for you. So these are several of them. This is the second derivative, and this, you just put this command and everything comes out neatly without solving. Like I said, this does not stop us from learning or knowing the steps. So this will just give us the answer. Then we can work towards getting the answer. All right, so let's move on. So here we have some special derivatives, some special derivative that we learned in class. So if you plot if you use dsolve to solve this differential equation, so this is the legendary differential equation. If you use that, and then to tell us that the solution is some special functions. So this is legendary polynomial, which will be the answer. This is what we are learning in class now for those in 301. And for us to compute the legendary, like we know in class that the legendary, when n is equal to 0, the p0 of x is equal to 1. So just put here, you write legendary p. Then you write the number here. If n is 0, if you are looking for p0, the n here should be 0. If you are looking for p1, your n here will be 1. So use it to solve. So we have legendary polynomial of first of first kind, and then we have the associated one. So, but what we're doing now in class is the legendary polynomial of first kind. So, if you put this in Mathematica, for example, if you put legendary P0 of x, it will give you 1. Legendary P1 of x to give you x, and legendary P2 of x to give you this. So the next one is the Bessel equations of order. New. So these are what we are doing now as well. So if you plug this chain inside your Mathematica, it will give you this special function, Bessel function. And here, for you to compute, put Bessel function of half. This is what will give us. Just if you have the Mathematica, you plug it in and see that this is what is going to give us. Okay, so I don't know if we have time to just practice some of this. So this is the what I've prepared today. So if we have time, we can practice some of this, especially what we're doing now in class, which is the use of polynomial, legendary polynomials.
Yes, I can. I think you can take 5 minutes, and then after 5 minutes, we can open the discussion for anybody else.
Okay. So now let's compute few of this, because this is what we're doing in class now for some of our students in 301. So let's see, for example, okay, let's stop. So if we say solve, so we want to have a legendary polynomial. P0 at x, this is 1. So P of 1, here 1, this is x. We know P2 also. Okay. So you can just compute as many as you want. And this is what we have done in class. Then the next is the Bessel. The Bessel function. For example, if you have Bessel function of half x, give us this, and then Bessel function of minus half. Then what of Bessel function of 3/2? So these are what we are doing for those in 301. Well, if we have done this, we're going to see meet them by Bessel. So if you have this software, because these are very difficult, these are special functions that ordinarily for you to compute by hand, it will be very, very, very difficult or even impossible. So we use this to get the answer. And finally, minus 3/2. Okay. So for the Bessel function, if we solve one of them, this solve, for example, we have y prime prime of x minus x squared times y prime prime of x minus 2 times x times y prime of x, and then plus let's use any special function, special listing.
You have twice y double prime.
Yes, this is the legendary equation. This equation.
Yeah, okay. You don't put it in brackets. You just spread the bracket. Okay.
Yeah, you can put it in brackets, no problem. Yeah, but it's easier this way to write. Then lambda times y of x, then comma, equal to double equal to 0. Then you put comma, you put your y of x, and then you put x, and you solve. So it will give us a legendary equation. So this is the legendary equation of the first kind. This is the second kind. So similarly, you can solve the Bezier. So I don't want to take much of our time again. So maybe I'll stop here. If anyone has any questions, we can entertain together.
Okay, thank you. I will stop recording right now.
Okay.